All right, so when we're factoring, we begin with basically what? Factoring a GCF. And then we also do factoring by grouping. So you want to make sure that you understand those two concepts. So the greatest common factor is where we begin. So let's look at a problem. So we have 18x squared minus 32xy. So one thing that you're going to realize is that when you start off, the directions are very specific, meaning they'll say factor the greatest common factor. And then as you move forward, the directions are just going to say to factor completely. So this is a binomial. So we look at it and we see that you should always check for descending order and a greatest common factor. So 18 and 32 have a common factor of something, a 2. So you would take that 2 and you would divide it out. And then when we look at the variables, they each have an x. So our GCF would be a 2x. And what is the GCF? It's almost like dividing it out of each term so that you know what's left. So I would be left with 9x minus 16y. And so when you look at what's left in the parentheses, you should always check to see if they still have something in common. So 9 and 16 don't share any factors. So then you would be finished. And you can always distribute it back. Remember to check the original problem, right? So factoring the greatest common factor is you looking to see, is there a common factor, and factoring that out, right? All right, anybody have a question on the greatest common factor? If you do, you have to unmute. All right, so you have the greatest common factor, and then after the greatest common factor, you have being able to factor by grouping. So factoring by grouping is what we use when we see 4 terms present. And then usually our directions would always tell us also to factor by grouping. So let's look. So when we factor by grouping, we should always have 4 terms present when we're factoring by grouping. So when you factor by grouping and you see your 4 terms, your first thing is always to split your problem in half. You basically put it into 2 groups. And then you're going to factor the greatest common factor from each group. So in my first group, I'm looking at 5x plus 15. So the GCF there is a 5. So when we factor 5 out, we are left with an x plus 3. Remember, when you factor out the GCF, it's almost like you're dividing by that factor. And then in the second half, the GCF would be a positive, because the sign of this first term in the second group always is the sign of the GCF, and they both share only a y. So you can have one y, or you can just put y. And so when you factor by grouping, right, the first parenthesis and the second parenthesis should always match. So when I divide this y out, I know I should end up with an x plus a 3, which I do. So when you see your parentheses match, you know you did it correctly. So then you factor out that common factor. So that common factor is x plus 3 and the 5 plus y combined together in the parentheses. Okay, so factoring by grouping. All right, any questions on that one? You just have to unmute yourself. All right, so let's look at another one. So GCF, greatest, and factoring by grouping. So that's your 4 terms. Then you have, when we're factoring a greatest common factor out of a problem first, and then having to factor the problem. So let's look at this. All right, so here we have 6a squared plus 9ab squared plus 6ab plus 9b cubed. So when we look at this problem, you want to make sure you remember that the very first rule is to always check for a greatest common factor. And so yes, it's 4 terms and we have to factor by grouping, but you're always supposed to look for a GCF before you do anything. So 6, 9, 6, and 9 all share a 3. And so when we look at the variables, they all don't have the same variable in order to pull out a variable, but we can pull a 3 out. So we would be left with 2a squared plus 3a squared plus 2ab plus 3b cubed. So once you pull out and factor out the greatest common factor, then you have to check what is remaining in your parentheses to see if you can factor it further. So I have 4 terms here, so I'm gonna see if I can factor by grouping. So I'm gonna split it. So I'm gonna just let him sit here because I can't mess with him while I'm doing my factoring by grouping. So I have a GCF of an A. All right, I have a GCF of an A. Then in the second group, I have a GCF of a positive B. So the parentheses match, so I know my problem is correct. So 2a plus 3b squared times a plus b, and the GCF comes down in front. So just make sure you remember that for all factoring problems, you should always check for a greatest common factor before you actually try to factor the problem. Okay. All right, factoring the greatest common factor, factoring by grouping. Any questions? Okay. So then we have factoring trinomials, which is when we have 3 terms. When we have 3 terms, okay? So x squared plus 7x plus 6. So when we're factoring trinomials, you should always look for descending order. So this is in descending order, meaning your variables count down in order. So I go from 2, 1 to no variables at all. Then you should check for a greatest common factor. So I don't have a greatest common factor here. So then we're going to factor our problem. When we have an A is 1, please remember that when we factor trinomials, trinomials are of the form ax squared plus bx plus c. And so the A is representing the leading coefficient. So in this example, the leading coefficient is a 1. So we're doing factors of 6 that can create the 7, right? Factors of 6 that can create the 7. So factors of 6 that can create the 7, when we look at the options are a 1 and a 6. And so 1 and 6 can create the 7 for us. So if we do a plus 1 and a plus 6, we would get a 7. And if you multiply those numbers, you would still get the 6 back. So you have to make sure that they can add, subtract to create the middle. And then you have to make sure that they can multiply to create the C term. So then you just do the parentheses, x plus 1, x plus 6, and your problem is finished. And when you're factoring, you can always check by what? Distributing it back. So most of your work for your factoring is going to be scratch work, is you trying to identify what are the factors that create this trinomial. What are the factors that give me this answer? So let's look at this. N squared plus 10n minus 24. So n squared plus 10n minus 24. So again, we're factoring here. So we're factoring the trinomial. The leading term is A, it's just a 1. So I'm just going to do what? The factors of 24. So factors of negative 24 that can create the positive 10. So it's a numbers game when you're factoring. So 1 and 24, 2 and 12, 4 and 6, 3 and 8. So when I look at those pairs, which pair can give me the 10? So what do we think? Well, some people might think the 4 and the 6. Does somebody have a question? So some people may think the 4 and the 6. So when we do the 4 and the 6, it would be 4 plus 6, which is 10. But what happens when you multiply the 4 and the 6? When you multiply the 4 and the 6, they would create a positive 24, not a negative 24. So that can't be the pair. Well, is there another pair that might work? Well, 2 and 12 could possibly give you a 10. And so when you check those, what would give you the 10? Well, if you use a negative 2 and a positive 12, you would get the 10. And if you multiply the negative 2 times a positive 12, you would get the negative 24. You should always double check your numbers because the whole point of factoring is a numbers game. Everything is about finding the right pair. And so the 4 and the 6 wouldn't give me the 10 and the negative 24, but the 2 and the 12 do. So my two sets of parentheses, I have an n to create the n squared, and then I would have a -2 and a +12. And if you multiply that out to check it, n squared plus 12n minus 2n minus 24, n squared plus 10n minus 24. If you multiply your answer out and get the original problem back, you know you did it correctly. Okay. All right, any questions there? Unmute yourself if you do.
I'm having trouble with it.
Okay, with the ones like this?
Yeah.
You have one?
No, I'm saying like I don't get it. Like it don't make sense to me.
What?
Like all right, so you saw how the 1 and the 6, right? It got you for that problem. Yeah, for the one, you know how like the 1 and the 6, right? Like I'm not getting the middle part, like how to find the middle part. Because like I always find the outside, but wouldn't find the middle, and that's the part where I get stuck at.
So you have to use the factors, right? So what numbers can multiply to create a 6? And then out of those pairs, which pair can add or subtract to create the middle? So when you're looking at your options and you have a 1 and a 6 and a 2 and a 3, and you see the 7 in the middle, your mind is saying, okay, what pairs of factors here can add or subtract to ever create the 7? So when you look at the pairs, your mind says, well, 1 and 6 can create a 7 or a 5. 2 and 3 can create a 5 or a 1, right? And then we can do negatives. So the only pair I'm thinking I can work with is the 1 and the 6. And then you figure out how can they create the positive 7. So you have to be able to think in terms of addition and subtraction after you list the factors. Because when you list the factors, this is about multiplication. But when you're looking for the pair, it's about adding and subtracting. Does that make sense?
A little bit.
So when we look down here, the number is a negative 24. So the factors of 24, 1 times 24, 2 times 12. Some people will have to use a calculator and divide numbers. 3 times 8, 4 times 6. So all of these numbers multiply to create 24. Now I know that I need a negative 24 though. So when you look at the pairs, which pair do you think can give you a 10? So when we thought about it, I said, okay, some people might think the 4 and the 6 could give them a 10, and it can. But what can you do with 4 and 6 to create a positive 10? You would have to do +4 plus 6 is +10. But do those numbers multiply to create the C?
You're right.
And if they don't multiply to create that C, then that's not the pairs. So if I multiplied a +4 times a +6, it would give a positive 24, and we need a negative 24, which means that's not the pairs. It's like going all around the town looking for Cinderella for the right foot to fit in the shoe. Like it has to fit the product and the middle. So when the 4 and the 6 don't create the product, you have to look to see if there's another pair that might work. So 1 and 24 can never give me a 10. 2 and 12 though, I could try it, right? So you have to play around. If it's a 2 and a 12, and here's the thing, when you understand your signs, this is a product of a negative 24, which means to multiply, the numbers have to have what? Different signs. If you need numbers to multiply to create this 24, there's no way that they can both be positive or both be negative. They wouldn't create the negative 24. And so automatically, when you have rules about your signs, it's easier and it takes you shorter to pick the factors. So when I look at 2 and 12, I need a positive 10. So right there, the larger number should be positive. And if I multiplied those two, it would give me the negative 24. The double check is everything. The factors is everything. All of the work is scratch work. All of the work is you playing around with the numbers.
So it's really me playing a guessing game.
Well, it shouldn't be a guessing game. It should be, you know how to add and subtract. I mean, it's a guessing game, but you have an idea when you look at these factors. Would you have tried 3 and 8? You could have tried 3 and 8, but your mind is supposed to be able to look at 3 and 8 and say that can only create a 5 or an 11.
True.
2 and 12 can only create a 10 or a 14. You understand what I'm saying? So how much energy you put in working on your numbers everybody's going to have a different amount of time, because it depends on how comfortable you are with numbers. But yes, it is a numbers game. It's just you playing around with the values. Correct. Because remember, we're trying to go backwards and figure out what multiplied to create this trinomial. So it's just playing around with numbers. Yes. All right. So let's look at another one and we'll see how you do, okay?
All right.
All right, mute yourself. All right, so then let's look at this one, a longer one. Let's look at 2x cubed minus 18x squared plus 40x. So looking at this problem here, first of all, it's in descending order already. I have 3, 2, 1. So you always make sure your exponent values count down in order. Then I see there's a greatest common factor present. Everybody shares a 2 and everybody shares an x. So when I factor out the 2x, I'm left with x squared minus 9x plus 20. So once your greatest common factor is factored out, you look at your parentheses to see if you can factor what's left. So what I have left is an x squared minus a 9x plus a 20. Well, what's that mean? It means I'm looking at factors of 20 that can create a 9. So when I list the factors of 20, I got 1 and 20, 2 and 10, 4 and 5. Well, which pair do I think can create a 9? I think a 4 and a 5 can create a 9. And this is where your knowledge of your signs is going to help. It's a positive 20. What do I know when numbers multiply if they create a positive outcome? If something creates a positive product, it means the numbers you multiplied had the same sign. So in order to get a positive 20, we would have to have both of the factors to be negative or both of the factors to be positive. So I know 4 and 5 can give me a 9. What do I need? I need a negative 9. So in my mind, what do I think? Negative 4 minus 5 is a negative 9. And if you multiply a negative 4 times a negative 5, it would give you a positive 20. Double check. And so depending on the number and the list of factors, some numbers are going to be easier to identify than others. But I can tell you that when students choose to be lazy and not just try the numbers out, like, you're going to end up getting it wrong. Just take your time and go through it. But I wouldn't take my time with 1 and 20 because I know 1 and 20 could never give me a 9. 2 and 10, I can get a 8 or I can get what? A 12. And then you got 4 and 5. So when I do my 2 sets of parentheses, it'd be x minus a 4, x minus a 5, and the 2x comes down. All right, did that clarify? Was that better? Question. You can unmute yourself.
Oh, yeah, that one was better.
Yeah, do you understand? You just don't sleep on listing the factors. I can tell you right now, you should have a list of factors on every factor and problem you do. If you are not listing out factors because you are trying to do it in your head, you will not get out. You will not finish. You have to be very good with your numbers to not have to write anything down. So everybody should make sure you should always have your list, and then you just go through your list. Okay. All right, any other questions on the factoring when the A is 1? So these are factoring trinomials where all of our first terms were 1. All right, any questions there? All right, so then this is kind of like the trial and error method, what I just showed you. So I only do the trial and error method when the A is 1. When the A is not 1, I use the AC method, or what we call the grouping method. So the AC method is when your A is not 1 in your trinomial. So let me show you what that looks like. 8x squared minus 13x plus 5. So here we have a trinomial. It's in its descending order already. There's no greatest common factor. So then I go to my next step, and usually it's look at the factors of the last term. But you can only just look at the factors of the last term when the A is 1. So I can tell you right now, so the way that I'm gonna show you is I do AC method. So if your teacher does trial and error, that's not a problem. Trial and error is just you guessing numbers, but I just think AC method is easier. So when your A is not 1, you do what we call the AC method, and you create the product using the A term. So you do A times C. So A times C would give us a positive 40. So then you do factors of 40 that will create the middle negative 13. So A times C, 1 times 40, 2 times 20, 4 times 10, 5 times 8. So what I do is I just start listing factors of 40, and I'm looking for a pair that I think will give me a 13, and I need a negative 13. Well, I think the 5 and the 8 can do that for me. So 5 and 8 can create a 13, and they'll give me a 40, obviously. I need a negative 13. So negative 5, negative 8 is negative 13, and if you multiply two negatives, you would get a positive 40. So that's my double check. I can add them together, multiply them, and still end up with what I need. So you check to make sure you get the AC, okay? So AC is when you have to do the A times the C, and then you find your pairs. Once you find your pairs, you create a 4-term polynomial. So once you find the pair, you're going to create a 4-term polynomial like you did in 6.1 so that you can factor by grouping. So you create 4 terms so that you can now just factor by grouping, and you just do what you already know how to do, because there's no way you should be in 6.3 or 6.4 and not know how to do 6.1. So you're going to make your problem look like a 6.1 problem so that you can just do what? Split it. GCF of the first group is an X. GCF of the second group is a -1. My parentheses match. I'm looking at 8x minus 5 times x minus 1, and you're finished. It's 3 lines. All of your work was scratch work. All of your work is scratch work.
The -1. How did you find the -1? Because you brought down. I know you got to bring down the sign of.
Correct. So I brought down a sign, and 8 and 5 only share a 1.
Okay.
There's no GCF, so you have to just use the 1 when they don't have anything in common. They only have a 1. So you have to use the 1.
Okay.
Yeah. All right. Other questions on that one? All right. So let's look at another one. 2x squared plus, oh, that's all right. 13x. I hate to get 13 again, but it's fine. 2x squared plus 13x minus 7. So it's in the correct order we need it in. We don't have a greatest common factor. So what are we going to do? Now, here's how you can always catch yourself when you're doing these, if you just start doing the factors of the last term. So if you're just going through it and you say, oh, factors of 7, that'll give 13. And you'll be like, wait, that doesn't even make sense. Always check the A term and see if there's an A, because then you'll say, oh, I have to do A times C. So A times C here would be a what? A -14. So we want factors of 14 that will somehow create a 13. So out of my pairs, which pair do we think would work? Well, we think the 1 and the 14 can create a 13 for us. So what would we have? Well, the 14, the product is negative. That means the signs of the numbers I use have to be different signs. So in order to get a 13, a positive 13, we would do -1 plus 14. Well, how do I know that? I know that because I know if the middle sign is positive and the signs are gonna have to be opposite, the larger number would have the sign of the middle sign. So in order for me to get it, or I can just know -1 plus a 14 is a 13. So you have to choose, right? You either understand how to get the number or you follow your rules. And then if I multiplied -1 times 14, I would get -14. So I get double check. Once you know your factors, that's everything. So I'm just gonna create the new problem. And it doesn't matter who you put first. You can put the -1 first, you can put the 14 first, as long as you put them in the middle to create the middle term. So then we're gonna split it, and so we're gonna factor by grouping. So 2x leaves me with x plus 7. -1 is gonna leave me with x plus 7. So x plus 7 times 2x minus 1, and that is it. And again, always distribute it through 2x squared minus 1x plus 14x minus 7 plus 13x. All you have to do is make sure that you can create the original trinomial. And if your answer multiplies back, you good. So that's it. Factor completely. All right, any questions on that one? Okay. Let's do one with a GCF.
You could do like one of the big problems like they give on the homework.
What's that mean?
Like, all right, they'll give us like 8x squared plus like 153 minus 49 or something like. It'd be like something like that.
What? They should have a GCF on those problems.
So for those problems where you just do the find the GCF first.
They're gonna have large ones, but they shouldn't be obnoxious. Like usually the ones that are obnoxious have a greatest common factor.
The one I had, I just looked at it and let it be. I got mad.
Yeah, you should send me those, or you should just like write it down. So I'm trying to find one that's big. I don't even see one that's that big that doesn't have a GCF. Well, here's one. Let's try this one. 36x squared plus 55x. The reason I don't like to do these because they take up too much time. Like, yeah, you might have to do it on your homework, but what I look like, I'm volunteering my services right now, and then you want me to be up in y'all shit looking up numbers. All right, so 36x squared plus 55x minus 14. So like this is one kind of like you mean, because when I look through this, like there's no greatest common factor here because the 55 only has 5 and 11, and that doesn't go into them. So now we're gonna have to do an AC of 36 times 14. So 504. So I know it's 36 times 14. So now we gotta take our time and start just finding, okay, what can divide into 504? When you have 3 digits, I can tell you wanna try to figure out what can divide in there for 126. And you're just gonna keep breaking stuff down and just see what can divide in it. And just, that's all I'm doing. I'm using my calculator and I'm just dividing numbers in it.
Mm-hmm.
And 9. And so I'm just really, when I look at 36 and 14, I'm gonna tell you how I'm picking numbers to choose. I'm just picking numbers that I know are inside of 36 and 14. So like, I'm gonna divide by 7 next because I know 7 is inside of 14. So
I'm sorry, I couldn't hear you. Can you repeat that again about finding numbers?
Oh, so I have this pair 36 and 14. So I'm dividing by factors that I know are inside of 36 and inside of 14. So I picked 4 because 4 is inside of 36. I divided by 9 because 9 is inside of 36. I divided by 7 because 7 is inside of 14. So that's how you know like what numbers you can choose when you see the other factors. Use numbers that you know divide into the other numbers. So what else can divide into 36? 6. So 84 and 6. I'm just telling you how I'm picking numbers. So I'm just choosing numbers that are listed here and ones that I know have factors. So the closest one we came almost was the 56 and the 9, but that does not give 55. So you just gotta, it's a negative 504. All right, so we just gotta keep trying. 504 divided by 3. I need something bigger. What else? Oh, 12. 504 divided by 12. 42 and 12. What else can go into, oh, 18. 504 divided by 18. 28 times 18. So literally, because this is so big, you have to like keep trying. So I totally feel you, but once you know a process, you know a process. So 28 and 18, we getting close, but it ain't happening fast enough. 46. All right, so does anybody else have a calculator? I needed to tell me what else I'm missing with dividing by this these numbers.
It could be divided -8.
By what? By 8?
Yeah, divided 8.
63. Yes, thank you. So 63 and 8 would give us a 55 if we subtracted them. Yes. So literally we had to go to 8. Yes. Because 56 has an 8 in it. All right. So literally the bigger, you never want the number to be that big, but it's possible. But understand, like, it just takes time. You just got to find all the factors. And you can't say it's prime until you have listed all the factors, right? You can't say it's prime until you've listed all the factors. So I totally feel you when you're like, man, I'm not working this problem. I mean, look, no, you do everything else. And then if they got one that's ridiculous, be like, whatever. Like, you got to make your own decisions, but just make sure you know how to do make sure you know how to do the process. Like, these problems are anomalies. Can you do the work is what you want to do. So 63 and the 8. So we would need a positive 63 and a negative 8, which would create the positive 55. So we would do 36x squared plus 63x minus 8x minus 14. So as you see, everything we did, all of the time we spent was finding the numbers. And now here, I'm gonna just split this problem and do the GCF. So 9x, 4x plus 7, minus a 2, 4x plus 7. So once my parentheses match, I know I'm good. 4x plus 7 times 9x minus 2. Done. So what you do is, as you get numbers, you just use factors inside of the other numbers to keep checking. And you just see what divides in it to create it. Okay, and then you just make sure you can find a pair that gives you that middle. But you can't say there is no pair if you don't list all possibilities. So sometimes students stop trying and just say, oh, it's prime, nothing works. But you can't say that. You have to really put in the time. Does that make sense? Did that help? As you can see, like, it's all a numbers game. You just got to sit there and try it. But the process isn't any different. All right, questions? Does that make sense? Yes?
Yeah, it makes sense.
All right, so then you have, so that's factoring trinomials. I'm gonna give you guys one just to make sure you can do it and see if you have any questions, and then we'll do binomials. So try this problem real quick and let's see. This will be easy. 8x squared minus x minus 9. Factor that for me. You try to factor that for me, and we're just gonna make sure that you know what to do. All right, and we should know that this middle term, we're trying to get a what? -1, right? A negative x means a -1. All right. So hopefully you did A times C, and A times C would give us a negative 72. If you do trial and error your way, that's fine. So A times C is negative 72. So I list factors of negative 72. I'm gonna use the 8 and the 9 because I know they can create a negative 1 for me. So to get the negative 1, I would need the 9 to be negative, the 8 to be positive. That would create the negative 1 and multiply to create the negative 72. So I create the 4 terms. Now remember, you don't have to have the 9 first. You could have plus 8x, then minus 9. That's fine too. So when we factor it, we should have 8x minus 9 times x plus 1. All right, how did we do? Does anybody have a question, an issue, a problem with that problem you worked? Just unmute yourself if you need anything. No? Did we do okay? All right, so that's factoring trinomials. Does anybody have any other questions from factoring trinomials? Okay. All right, so then you have, when you have 2 terms, so you have to be able to factor all types of polynomials. So the next step is factoring binomials. That's when we have 2 terms. So factoring binomials, that's when we have 2 terms. So when you're factoring binomials, it's basically the same 2 rules like trinomials. Is it in descending order? And can you do a GCF? The only thing that's different is you check for a GCF, and then you have to check for the difference of 2 squares. The difference of 2 squares. So difference, make sure you understand difference means subtraction, and 2 squares means perfect squares. Right? It's a number that has the same 2 factors, a number with the same 2 factors. So let's look at this. Let's look at x squared minus 4. X squared minus 4 is a binomial, and I know that because it's only 2 terms present. When I look at it, it's in descending order and there's no greatest common factor present. So your last thing you have to ask yourself is, well, is it the difference of squares? Meaning, can I factor it? So if it's the difference of squares, which this is, we can factor it. So the difference of squares means a squared minus b squared. So it means your first term is a perfect square, and then your subtraction, and then your second term is a perfect square. So it factors into an a plus b and an a minus b. So here are 2 sets of parentheses. The x squared was split into a what? An x and an x. And what would the 4 split in? Well, you do the square root of that one, right? So what creates the 4? What 2 factors create the same 2 factors? 2. So one's a plus, one's a minus. And that's it. So the difference of 2 squares is what you're going to look for beyond factoring a GCF when you have binomial problems. So let's look at this one. 2x squared minus 18. So 2x squared minus 18. So we have 2 terms. It's in descending order. Is there a greatest common factor? There is. So we have to factor out that GCF, which in this case is a 2. So when I factor that out, I'm left with x squared minus 9. Well, now, as always, after you do the GCF, what do? You have to check to see if you can factor what's left in the parentheses. Well, this is the difference of 2 squares, right? X squared minus a 9. A 9 uses the same 2 factors. So we do 2 sets of parentheses, x, and 9 is going to be what? 3 and 3. One's a plus, one's a minus. Okay? So the difference of 2 squares, that's us factoring the difference of 2 squares. So when we're factoring binomials, we have to check to see, is it the difference of squares beyond just a greatest common factor. Okay.
I have a question. The final, how it's supposed to look, is it supposed to be like parentheses x minus 3 to the second power? Because instead of having it factored out.
Oh, so that's when the factors are the same. So that's like if we have a problem like this, x squared plus 6x plus 9, the factors of 9 that give us the 6. That's when you have the same factors. See, x plus 3, the difference of 2 squares is factors, it's a subtract here. And so the signs have to be different because there's no middle term. So when you're doing the difference of squares, the signs always have to be opposite to actually multiply back to create what you need, because the middle is gone. When it's when you have the same exact factors, that's when you can do x plus 3 squared.
Okay.
This is two different signs. Yes, this is a perfect trinomial. This is a perfect square. So the perfect squares are only when it's two terms. Perfect trinomials are when you have the same two factors and it's a trinomial that you need.
Okay.
Yeah. Okay, good question. All right, anything else here? All right, so let's look at two more for the greatest common factor. I mean, for two terms, I just like to show you this. What if we have 2y squared plus 18? So I like to just show this 2y squared plus 18. We can factor out a greatest common factor here, and we would be left with y plus 9. Please understand this problem would be finished because we cannot factor the sum of two squares. So this is a binomial. We factored out a GCF, and when we look at what's left, it's a sum, not a difference. So there's nothing we can do here. Now, a lot of people try to do like we just did and say y plus 3 times y plus 3, but it's important for you to understand that the same two factors will always create a trinomial, and we need a binomial. So see, this creates plus 6y. So when you have a binomial, two terms, and you're trying to factor it, you can't factor the sum of a binomial. So this problem here would be finished. That's it. It's factored because there was a greatest common factor. But if you see one where it's like x squared plus 16, there's no greatest common factor here, and it's the sum of two squares. So this problem would be considered a prime, right? So you cannot do the sum of squares. You can only do the difference of squares. But if you factor just a GCF, then that means you factor. Okay, so some students think if you only can do a GCF, then after that it's prime. No, if you factor anything out of it, it's a factored problem. This one, there was nothing we can factor out, so that's why it's originally a prime. So just make sure you remember that you cannot do the sum. The vocabulary is very specific. Difference of two squares. It's got to be a subtract, okay? So that's factoring binomials.
Teacher, can we write 2 and between brackets y plus 3 power 2?
Are you asking me to do a problem?
Yeah, at this problem, can we write 2 and between bracket y plus 3 power 2?
Y plus 3 to the second power?
Yeah. Can we write, can we solve this problem like that?
This one?
Yeah.
No, that's what I just showed you. Y plus 3 to the second power means this. Y plus 3 times y plus 3. And that's what I'm telling you. You cannot multiply two binomials together that are the same and create a binomial. You see, it doesn't create this. Factoring means you should be able to create what you originally had. If I factor this, y plus 3, it would create y squared plus 6y plus 9. It doesn't create y squared plus 9. You can't create a sum of factors. You can't factor the sum of squares. There is no two binomials that can multiply to create this. So it can't be done. This is what it factors from the trinomial, not this. Okay? Yeah. All right. Other questions? Okay. And then the last thing, I don't know if y'all did that, but being able to solve by factoring. So once you can factor, then we bring in previous material. So we learn factoring and then we bring in solving. So now we're putting things together. So when we solve by factoring, it's important to understand that the equation has to equal 0. So in order for you to solve by factoring, the equation must equal 0. The equation must equal 0. Okay, So you always have to start where your problem is equal to 0 in order for you to solve by factoring. So let's look at a problem that we have to factor. All right, so let's look at x squared minus 13x plus 36 equals 0. So when we look at this problem, our directions are going to tell us to solve. One thing you're going to have to keep straight, because we always want to keep focused and remember, we do have a comprehensive final exam, and we want to make sure that we realize we are not forgetting old information, we are building on it. So when we look at an equation, we know we have to solve because an equal sign is present, but the directions would always tell us to solve anyway. When you look at a solved problem, now you're going to have to look at the variables to see if you have exponents present, because if there's exponents present, then you're going to have to solve by factoring. But we want to make sure we remember that we also need to be able to solve a regular equation that doesn't need to be solved by factoring. All right. So here I have an equation that has an exponent. So that automatically tells me I'm gonna have to factor this problem. So remember in the previous chapter, we would start trying to isolate the variable. Well, when we're solving by factoring, we don't want to isolate at this point. We have to factor it first. So we're going to factor this trinomial. So once you make sure your equation equals 0, then you're just going to factor. So I'm going to factor factors of 36 that give a 13. So you go through your factors of 36. So I'm going to go with 4 and 9. Okay, 4 and 9. So I'm going to do my 2 sets of parentheses. And why can I just go straight to 2 sets of parentheses? Because my A is 1. Okay, but there's nothing wrong if you want to do the 4-term polynomial. So I'm going to just show you that way too. So if you want to do it the way that we just did, you can do that for all types. So I could just do this, minus 4x minus 9x plus 36. So I can create the 4-term polynomial and factor. So I would get an x minus 4 and an x minus 9. And then I'm going to bring down my equal 0. So you can factor it however you factor. So I factored my problem. I got x minus 4 and x minus 9 is equal to 0. Once you have it factored, you're going to set each factor to 0. You set each factor to 0. So you have 2. You're going to create 2 new problems. So you have x minus 4 equals 0, and we're going to have x minus 9 equals 0. So we just set each one equal to 0. All right. And so when we do that, now we have equations that we know how to work because we know how to solve for these x's that don't have variables on them. Exponents. X minus 4 equals 0. I'm just going to plus 4 on both sides. I'm trying to isolate the x. Here, I'm going to add 9 to both sides. I'm trying to isolate the x. So what is x equal to? X can be 4 or x can be 9. So you factor your problem, and what you have to do is, we don't know how to solve things with exponents on there. Chapter 2 didn't tell us anything about exponents. All we knew how to do was isolate variables that have exponents of 1. And so you're going to break these factoring problems down so that you can get variables without the exponent on it. And then you just do it that way. So after you set each factor equal to 0, you simply solve your problems. You solve your equations. Okay. All right. Questions about that example? Okay. So once you can factor, you can solve by factoring because you're just building on the same information. X squared minus 7x is equal to 0. So here it's a binomial. And so you're going to have to go through, okay, so is there a GCF? Yes, there actually is a GCF. So what is the GCF? An x. So I'm left with x minus 7 equals 0. So when I look in the parentheses, I can't factor that anymore. So my problem is factored. Well, what do you do once it's factored? You set each factor equal to 0. So I have an x equal to 0 and I have an x minus 7 equals 0. Well, x equals 0 is already solved. How do I know that it's solved? Because the x is isolated and there's nothing more for me to do. Here, x minus 7 equals 0 needs to be solved. So how do I solve it? I need to move the 7. So the 7 is going to add to itself, cross the equal sign, add to the 0. So what are my answers? 0 and 7. And we're finished. Okay. So if you can factor, then you just use all your rules after you factor and you set each factor to 0, okay? So every time we have these, everything's not gonna always equal 0 already. So sometimes we're gonna have to do some work. X squared minus 5x is equal to 24. So this is a problem where there's work we have to do first, because we have to get it equal to 0 before we can solve by factoring. So the 24 is gonna need to move to the same side as everything else. So when we're factoring by grouping, we're actually factoring, we have to put everything on the same side so that we can factor it. So the 24 would move by subtraction. So you just write it in descending order because he doesn't have a like term or anything. And then we're gonna factor. So factor the 24, that'll give us the 5. And again, you factor however you're comfortable. So this doesn't have an A, so I'm gonna just do our 2 sets of parentheses for this one. So factors of 24 that give a 5. So it's gonna be a -8 and a +3. So my problem is factored. Now all I have to do is set each factor equal to 0. So x minus 8 equals 0, x plus 3 equals 0, and then I solve for each x. So as x is equal to 8 and x is equal to -3. So when you put in your answers, they're gonna tell you just separate your answers by commas. So 8 and -3 would be the answer. Okay. All right, any questions about that? Any problems, questions, issues? Unmute yourself if you do. Did y'all get to this already? In the class, in your classes?
Yeah, we're on the word problems now.
Oh, okay. All right. Any questions about the solving by factoring? Anybody have any issues that they brought with them that they needed me to address? You can unmute yourself. Nobody got no questions? Y'all okay? You can unmute yourself, talk to me, tell me something. Unmute. Tell me if y'all okay. Do we need anything else? Does anybody need anything? Do you need anything else worked?
No, it's okay. It's fine.
I'm trying to think.
So if not, I don't have anything else, but if anybody needs anything worked or have a question on anything, I can do that for you.
Can we go back over 6a squared plus 9ab squared plus 6ab plus 9b cubed?
Yes. Let me find it. I have it in my book. All right. 6a squared. Let me erase all of this. Plus 9b squared. All right. So this was our factor by grouping. Okay. But there's a greatest common factor that you have to check for. So what I did was first, everybody had a common 3. So let me ask you a question. Were you thinking about just splitting it first? Or did you
I think I got kind of mixed up when a little bit when I think you had to factor it out. Like I was trying to figure out, okay, it's 2a plus 3b squared. I kind of got like a little confused by the letters, I think.
Okay, all right, so 2ab plus 3b cubed. So when we pull out a 3 because that's the only thing they all have in common. So then we bring everybody down when we divide out the 3. So the 3 sitting outside, that leaves us with 2a squared plus 3ab squared plus 2ab plus 3b cubed. So now we have to factor the remaining polynomial. So now this is where I split it. So in the first group, the 2 and the 3 would have a 1 in common, and then you would pull out an A for the GCF. So the 3 gonna sit here. So when I divide out A, I'm left with 3B squared. So A divides out of here, which leaves an A. A divides out of here, which leaves no A, and then the B squared comes down. You see that?
Yeah.
All right, so then in the second group, the only thing they share is a B. So it's gonna be a 2A plus a 3B squared. So once you see the parentheses match, you know you did it correctly. So 2A plus 3B squared times A plus B. And then the 3 comes down in front. So sometimes you may need to show your division underneath each term so that you can see how the variables cancel and the exponents change. So yeah, so I always recommend students to like show your dividing through your code, your GCF, so that you can see what happened. All right, does that make sense? Was that helpful?
Yeah, that makes sense. Thanks.
Okay. All right, anybody else need anything? Factoring is a huge chapter, you guys, like no lie. If you can factor, chapter 7 will be a breeze. So chapter 6 is really important for you guys to make sure that you practice with because the first 2 sections of chapter 7 is just factoring. I'm just not even gonna kid. So when you get used to it, it makes chapter 7 really, really easier. All right. So if there's not anything else, then that is it for me. Contact your instructor if you need any help on anything. And that's it. I hope it was helpful. Please leave your name, your instructor's name in the chat to me, please. Just send me a private message with your name. You don't have to put your name. Your name is usually on your stuff. You could just put your instructor's name for me, please. I appreciate it.
The test will include section 7 of the chapter.
The word problems?
Yeah.
Did you have a question for them? I don't have any. So did you have one? Did you have a question on the word problems?
I ask it will be found in the test.
I think it's like 1. So I think it may be like 1 word problem, and I'm not even sure which word problem it is. So I can tell you that it's either just a solving by factoring. All of the word problems are really just to solve by factoring though. So it's either a solve by factoring where you just make it equal to 0, or it's the Pythagorean theorem, the a squared plus b squared equals c squared. And even if it's that, you're just plugging it into the equation, into the form. So it's either going to be a Pythagorean theorem problem, which are all just solved by factoring problems, really. The word problem is really just a solve by factoring. I just don't have any. So when you do your practice test or your quiz, they'll show you the examples, and it's only like 5 on the word problem section. So it's going to be one of those from the word problem section on your homework. So one of those types, that's all they're going to give you. So if you have any questions from that, just ask your instructor, because I don't really, like when you're working it on the system, send your instructor a question or just email your instructor a personal question, unless you have one for me to work.
Thank you.
You're welcome, because I don't want to do anything extra. I don't have them pulled up from my math lab. All right, make sure you leave your name for me. Anybody else, if you don't have any other questions, thank you so much for coming. I appreciate it. Do well.